what does agronomy mean and what makes it computational?
John, great to be here. So yeah, I grew up on a family farm, and as Feroz was talking there on the precision ag, I got to thinking back. So the first time we implemented precision farming on our actual farm was in 1995. We implemented
Whoa.
a technology that was called yield monitors, and so very simply, it's a mechanistic pressure plate. And so as the grain would go by, it would read different pressures, and that pressures through data science. I mean, this is old school data science, right? Was converted and calibrated to give growers bushels per acre. And that was really the first time that growers were able to move from what Feroz mentioned on field averages, because for up to that point, most all growers would be this farm yielded 180 bushel. But within that, every grower knew that it ranged from 220 to 120 bushels. There was variation that happened, but they would farm on the averages. And so, what is computational agronomy and what is agronomy? Agronomy is the science of growing, plants at the end of the day. It combines soil science, environmental sciences, as well as plant sciences. And agronomy really is the nexus to bring all of these disciplines together. In our own organization, we'll have plant breeders, we'll have soil scientists, we'll have climatologists, but agronomy is this nexus to bring all of those components together. So no different than you watering your grass out in your yard, right? Agronomy is used in turf management and in vines and grapes. It's to bring all those together to maximize production ultimately with the minimal inputs as you can. And so, what is computational agronomy? Well, this is the codification of those processes and principles, or the rules of crop science, as we would call it. And so, what does it mean for water to move from the ground into a plant and out the stomates, right? Transpiration. How does that work? And so, we really want to get into the science of that piece and codify it so that we can build these digital twins. We have to understand these principles so that we can replicate them in a computer and an environmental world. And so I'm sure we'll get into it, but we use many principles and many different components, from mechanistic models to machine learning models to empirical, all types of different models to represent and reproduce what I used to do as an agronomist, which was very manual, right? As I went to school, I learned all these sciences, put them into my head through memorization and study and education. And then I would walk into cornfields and soybean fields and diagnose what's going on. Is there a disease? Is there an insect? Is the plant stand cracked? Like all of these things visually and cognitively. And now what we're doing is taking that same components and converting them to machine learning and technologies. And frankly, the advent of machine learning and computer vision has just accelerated this. So it's an old hat. When I went to school, it was just called statistics. Now it's way cooler and called data science, but in the new technologies that come.
Yeah, that is exactly right. This this field, probably all four of us have been doing it for a while under the guise of statistics. But now, yeah, we have much more computationally intensive algorithms, and so I think that's part of why we end up calling it data science, this big umbrella term that captures not only statistics but also machine learning approaches that aren't statistics. But very cool to hear how computational agronomy is taking all of the things that you learned about optimizing yield and soil management, and piece by piece, I imagine you're kind of trying to say, okay, where is the next piece of low hanging fruit here, figuratively speaking, in terms of being able to, to say, what's the next thing that we can automate? How can we get a machine learning algorithm to learn this task, a machine vision algorithm to be able to capture the knowledge that you learned in school, Jeremy, and be able to ensure that plants are healthy, they're standing tall, and bearing lots of literal fruit. Um, so yeah, so let's dig into that a little bit more. So how are things like satellite imagery and remote sensing used to monitor fields already today and enhance operational efficiency? And then what do you kind of see happening as next steps? What are the next bits of, again, figurative low hanging fruit?
Yeah, I think just a little bit of the history on that as we move into some of these topics. I think, ag, we've been trying to solve a lot of these components and problems, as a point source, right? So trying to figure out how to do nitrogen management or stand counts or disease management. We've been really doing these as point source components when the reality is they're all highly interdependent, and it's a very complex ecosystem. Mother Nature is not easy, right? At that component. And so as we've gone forward, we have these multiple scales that we have to operate at. We have to operate and understand what's going on at the plant level. And so that's where we look at technologies like through phones and very close up camera and resolution so that we can take a picture of a disease and use computer vision technologies to identify and train those models so that the human force can be, scaled in 10x. And so they're able to very quickly go from what is on my plant to how to treat and recommend that plant. But that's at a leaf level. And then you're going to move backwards up at scale. And so around the world, depending on what country you're in, farm sizes have continued to get bigger. Whether you're in a country that starts with 1 hectare and they went to 5 hectares, they're still getting bigger in scale. Or if you're talking about in the US, Europe, Latin America, where they're in the tens and 20s and 30 thousands of hectares that growers manage. And so the complexity of management and scale of management has continued to grow. And so that's where we start looking at other technologies like remote sensing to be able to help growers monitor change management, right? Agricultural is through constant change because Mother Nature is not consistent. Weather and climate make a big impact on the plan that growers have for the crop growth and development. We may get drought. You can see the heat waves around the world, or floods or rains, and that changes how growers have to manage. And so this is where we really got to be dynamic in the data science to incorporate those environmental classifications to really understand the impacts. The law of the average in this world is definitely not going to work. We've really got to be dynamic in understanding when we see extremes, forecasting them, and what the impact of that is going to be into the growth of those crops around the world. So it really comes down to the scale that we're trying to manage, John. If we're trying to look at a plant level, we're going to use very specific, like Feroz mentioned, species level genetic information combined with data science on how to manage that, right? Is that specific genetics tolerant to a disease? Is it susceptible? So when I take that photo and I know that it's there in presence, what is the response we expect from that plant? Will it be able to hold off that disease or will it be susceptible? And then combine that all the way through to the recommendation. Because at the end of the day, the grower wants to know what action they need to take. And that's really what we try to do. We simplify and do all the complex data science internally, but really we just want to give the grower a recommendation of what they need to do as a next step.